This is question 4 on the review, and it says an object is launched directly upward at 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height, s, at time t seconds after launch is s of t equals negative 4.9 t squared plus 19.6 t plus 58.8, where s is in meters. So which statements are true? Now, a couple of things here. First, it says the object is again at the same height as the platform at 4 seconds. So what this is actually looking for is h of 4. So if I'm looking for h of 4, I have negative 4.9 times 4 squared plus 19.6 times 4 plus 58.8. So when I type that in my calculator, I have negative 4.9 times 4 squared plus 19.6 times 4 plus 58.8, and I do get h of 4 is 58.8. Now, you also need to remember that the same height as the platform, the height of the platform is just that c value, that initial height. So if that is my initial height, then I can go back to this function and see that my initial height was 58.8. So because this is 58.8, my initial height, this c value right here is 58.8, then that is a true statement. Then it says the object's initial height is 19.6 meters above the ground. Well, we just decided the initial height is just that c term because the initial height, remember, is s sub 0. So the initial height is just, so I think I said h right here. It could have just been s for all of these. But s sub 0, which if I put 0 in here, this term cancels out. This term cancels out because it's all 0. So I'm only left with 58.8. So the initial height is not 19.6 because it has to be 58.8. So that is incorrect. The object hits the ground after 6 seconds. So these two are going to be similar. And what these are asking for are the zeros. So this is when s of t equals 0. So if this is asking for the zeros, we need to solve this function. We need to set it equal to 0 and solve it. So we're trying to find the zeros. So s of t equals negative 4.9 t squared plus 19.6 t plus 58.8. So then 0 equals negative 4.9 t squared plus 19.6 t plus 58.8. So you could use whatever method you wanted to solve this one. Because of all of these decimals, I would probably avoid trying to factor. I would probably avoid anything, honestly, except for the quadratic formula, just because you do have zeros all throughout. So if I were to use, just because you do have decimals all throughout. So if I were to use the quadratic formula, A equals negative 4.9, B equals 19.6, and C equals 58.8. So then, quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then, when I use this to sub in these values, I have negative 19.6 plus or minus the square root of 19.6 squared minus 4 times negative 4.9 times 58.8 all over 2a, which in this case is 2 times negative 4.9. Now, in this case, I noticed that both of these are decimal values. Here, or not here, sorry, right here and here. So they're not necessarily decimals, but they're whole numbers. So it's 6 seconds and negative 2 seconds. So that means that I could type this in all as one expression and be fine. Now, if you do that, you need to be super careful about your negatives and about your parentheses to group certain things. So I have negative 19.6 plus the square root of 19.6 squared minus 4 times negative 4.9 times 58.8, close parentheses. I'm going to get out from under that radical. Be careful, I had to hit the over arrow in order to get out from under this radical. Divided, and I'm going to close that top. So this is closing that whole entire top. Divided by, in parentheses, 2 times negative 4.9, close parentheses. So all of that gives me negative 2. So one of my possible x values is negative 2. But I have another, because remember, when I sub this in, I used the plus sign. I can go up and highlight that and hit enter, and it'll bring the whole thing down again. And you can change this plus sign to a minus sign and hit enter again. And so my other value would be 6. Now if you wanted to do this piece by piece, that would be just fine too. So that means that on this sketch, I know that this value back here is negative 2, and this value up here is 6. This one does not matter because remember this represents time. I can't have negative 2 seconds. That doesn't even make sense that it hits the ground after negative 2 seconds. So because I can't have negative 2 seconds, I'm only going to have 1 0 in the real world application of this problem because that 6 is the only one of these x values that is applicable. So that would be this one. The object's highest elevation is at 78.4 meters. Now remember, to find the highest point, remember on this graph, the highest point, the vertex right here, is T height, so TS in this case. So to find that T, I need to find my axis of symmetry. So these two, the C, I guess that would be D and F on this one go together because my first part is to say x equals negative b over 2a. Or in this case, t equals negative b over 2a. So then when I fill in my values from my equation, from my function, I have negative 19.6 over 2 times negative 4.9. Negative b over 2a. So that gives me negative 19.6 divided by, I'm going to put it in parentheses because I want it to multiply it together, 2 times negative 4.9, and I'm left with 2. So my time is 2 seconds. The object reaches its maximum height at approximately 2 seconds. That's true. But then I'd have to take that 2 and put it back into my function. S of t equals, just like I did before, I'm going to say S of 2 equals, here's my function, negative 4.9 times 2 squared plus 19.6 times 2 plus 58.8. So negative 4.9 times 2 squared plus 19.6 times 2 plus 58.8. So that means that its highest point that it reaches is 78.4. So S of 2 is 78.4. The object's highest elevation is at 78.4 meters, so that one would be correct as well. So then, post any questions you have below.